Welkom allemaal bij deze keynote lecture van Dr. Alessio Fasano. Ter voorbereiding van de Food Dialogue vanochtend vroeg ik aan het publiek of het nodig was dat ik Dr. Fasano introduceerde. En toen mompelde iedereen, nee, dat hoeft absoluut niet, dat hoeft absoluut niet. Dus ik denk dat dat nu ook niet nodig is. Ik kan nog een kleine anekdote vertellen. Voor mensen die, zoals de meeste van jullie, met paleo en evolutionaire geneeskunde bezig zijn, is Alessio Fasano een soort Mick Jagger. Althans, wat was die voor mij. En het moment dat ik een mailtje naar deze man stuurde, voelde dan ook behoorlijk onzeker. Maar 10 minuten later kreeg ik een antwoord van, nee, dat gaan we regelen. Ik kan niet op die datum, maar kunnen jullie niet wat fixen met het verplaatsen van het symposium? Nou, dat hebben we natuurlijk gedaan, daarom was het wat later dit jaar. En ja, hij gaat een van zijn fantastische lezingen houden over, hij is de man op het gebied van gluten en non-celiac gluten sensitivities. En vandaag zal hij speciaal ingaan op de mysterieuze rol van het microbioom op het ontstaan van deze aandoeningen. Dus hij heeft aangekondigd dat hij ook met een aantal nieuwe dingen komt. Dus graag uw applaus voor Dr. Alessio Fasano.
Thank you so much. I really appreciate it. I don't know exactly what you said, but that's okay. All right, so we're going to shift a little bit gear for those that were, you know, at the food dialogue today, and go a little bit more in details. These are my conflict of interest, by the way, and again, we're not going to talk about anything like this. On really a shift of paradigm, in my humble opinion, on how we would take care of patients. A total shift of paradigm. Such a shift will imply there are no people that are right or wrong in terms of how to approach your care of patients. Traditional versus complementary medicine are not two different things that cannot eventually integrate their efforts, because there's a lot to learn if we have a little bit of open-mindedness here. And again, I will use throughout this chat celiac disease as an example that teaches us a tremendous lesson that indeed the approach is changing and is changing dramatically. Particularly when it comes to the complexity of these very, very multifactorial diseases like autoimmune diseases, where gene, environment, and as you will see, other factors, they really interplay. And because of the audience, but also because the evidence, the scientific evidence is really building, a lot of discussion will be on nutrition and how nutrition, genes, and a key organ like the gut and the gut mucosa may eventually, when they interact, come out with these clinical outcomes. They are chronically inflammatory diseases. And when I say chronically inflammatory diseases, I mean any disease that affects humankind. There is no condition, infectious, autoimmune, neurodegenerative, cancer, that would not have an inflammatory component. Of course, I need to start from Leiden. And with this Dutch pediatrician that was practicing here, that made the major discovery linking gluten to celiac disease. At this time, celiac disease was a pediatric disease condition, and again, as Fritz Koning would say, very severe. 1/3 of these kids would not make it. 35% of mortality due to malnutrition. Not because they were not eating, but because they could not make use of the food and nobody knew why. And he made a tremendous and important observation, very acute. During World War II, this mortality went to 0 and returned to 35% after the war. And he reasoned what we did not have during the war that now we have again. And the answer was, what? Flour that was made with wheat before the war was made with potato starch. And he hypothesized that was wheat the culprit, and did an experiment that could not be done again. He took 6 kids, put them on a gluten-free diet, showed that the symptoms were gone, re-gave them gluten, and showed that these kids got sick again. And that's how the connection between gluten and celiac disease in 1951 was made. So it's a recent history, and this pediatrician from Leiden is the one that gives us still the cornerstone of the treatment for celiac disease. He also taught us later on, when celiac disease was moved from a food allergy or sensitivity to a true autoimmune disease, because we now know that having celiac disease is like having MS, rheumatoid arthritis, type 1 diabetes, same story. And the recipe was, okay, you're born with the genes, many, because these are multifactorial, you're exposed to an environmental trigger that we don't know for all the autoimmune diseases, but celiac disease, thanks to Dickey, and that's enough or sufficient to develop the autoimmune insult that is the characteristic of celiac disease when the intestine is destroyed. That has been the paradigm that we've been working so far. As some people, they're still working these paradigms. Genes plus environment, necessary and sufficient. Then again, clinic throw us a curveball or put all this in discussion. What are the clinical factors at odds with this conclusion? Again, Fritz mentioned that there is no 100% concordance in homozygous twins. These are genetically identical. The genes that they have are the same. And they both eat gluten, but one develops the disease, the other one does not. Why? There is definitely a difference age of onset of the disease. At the Dickey time, the disease was a pediatric disease. Now, everybody at any age can develop the disease. Some people, they have symptoms that are specifically focused and limited to the gastrointestinal tract. These are the people, they have the classical symptoms of diarrhea, weight loss. Others, they have no GI symptoms whatsoever, but may have only anemia and fatigue. But most importantly, prospective studies, and there were some questions about that, undisputably show that eventually people at risk may develop this disease after decades they've been exposed to the environmental trigger gluten. And definitely, and in line with many other autoimmune diseases, we're in the midst of epidemics of celiac disease. It's in rampage. It's doubling every 15 years. Why this is happening? And the timeline here is way too short to blame genetic mutations as the reason why this epidemic is occurring. The message that is extremely provocative, I'm so glad that Fritz is not here, otherwise he would shoot me, is that we are not born with the destiny to develop celiac disease, or we are not born with the destiny to develop any chronic inflammatory disease. If we do or do not, strictly depends on our lifestyle. So it's totally in our hands. Back to the celiac disease paradigm, when we saw these epidemics, we asked ourselves the question that we asked, during this dialogue. What is driving these epidemics? Quality of gluten, quantity of gluten, the fact that we don't breastfeed our babies as we used to because mom now are extremely busy and they are forced against their will sometimes to not breastfeed their babies. What is really driving this? And we've been thinking and looking at the literature, analyzing retrospectively the data, and we come up with very controversial answers until two major groups, one from Europe, for which Fritz was part of, Prevent CD, and the other one for Italy and USA, did a study prospective in which babies at risk were recruited, and papers were published 2 years ago like this. 700 kids at risk, followed for 10 years. So this is not a joke. This is the real deal. No, extrapolations from metadata or, you know, retrospective analysis. This is the real deal. What we got out of this? Nothing. Nothing. A complete, stressful nothing. So the window of tolerance that we believed that was the best time to introduce, you know, possible allergens to babies between 4 and 7 months of age, it did not work. Breastfeeding, that we were absolutely sure that would be protective in both studies and independently, turned to be not. So if you're breastfed or bottle-fed, your destiny is the same. If you introduce a small amount of gluten, very small, early, in order to teach the immune system to tolerate it, it did not work. Neither worked to postpone the introduction of gluten after a year of age, so to allow the immune system to mature and be more ready to fight this enemy. The only two things that came out that had some meaning: GI infections in the first year of life seems to have a trend toward increasing the risk, and genetics. You heard about this HLA, DQ2, DQ8. So if you are somebody from the general population, 1%, if you're first-degree relative, 10%, if your first-degree relative say you have 2 copies, so you're homogeneous with this HLA, DQ2, you can go all the way to 30, 35%. So definitely the genetic counts, but you still have 70+% of the load that is not explained by genetics. And this brings me to the formulation of this hygiene hypothesis. Bright observation from somebody that in the late 90s said, you know, guys, look at this. What did I do? Did I turn this off? Oh my gosh. Well, can you see that? Yeah. No. It's not as bright as before. I don't know what I did. Mouse? I moved the mouse. Okay, never mind. Okay. So, bottom line is, during the 50s, when we went at war with microorganisms by using and abusing antibiotics with a massive, you know, intervention of sanitation and so on and so forth, we did a great job. The killers, the infectious diseases like rheumatic fever, TB, mumps, measles, almost disappeared. And here we're talking about the quote-unquote civilized countries, or Western countries, okay? The one above the equator line. During the same time, though, interestingly enough, coincidentally, we start to see these epidemics of autoimmune diseases. MS, Crohn's, type 1, asthma, in epidemics. And these epidemics were not seen below the equator. And therefore, it was concluded that we were getting too clean for our own goods. So rather than to die fast by infectious diseases, we were dying very slowly by autoimmune diseases. That was the essence of the hygiene hypothesis. The most remarkable epidemics that has been really recorded lately is the one on autism. I've never seen anything like this. This is scary. Now, it's not 50 years anymore. We're talking about 30 years if we go from 1 in 5,000 to 1, now it's 1 in 68. And if you consider the male-female ratio, it's 4-to-1. Next generation, 1 boy out of 4 will be out of commission because of autism. Unbelievable. What are we doing to generate these epidemics? What is going on here? Well, that brought us almost 10 years ago, when we start to see the accumulation of this, to a reformulation of the recipe for the development of chronic inflammatory diseases, including the ones that you see in rampage here. And again, even neurodegenerative diseases like Alzheimer, dementia are in the rampage. Well, definitely the two that we discussed before are still there. There is no question that you have to have genetic predisposition and exposed to something that the immune system reacts to that will be necessary. But these are not sufficient anymore. You need to have an intestinal barrier function that doesn't work anymore, so that these two worlds This, the world lives inside our body, and this is outside, can physically interact. Something has to be wrong with your immune system that has been built phylogenetically to defend us, and now start to really attack ourselves. And finally, because I will be, deceptive not to mention this, the microbiome is coming in big time as a key player, even if we're just moving the first steps towards, understanding how this works. Let me stop for a second because I spent already my first 9 minutes here. Are you guys okay, the pace that I talk, because I was talking a little bit fast this morning? If not, I will start all over again, and we're not going to have the drink, and that's not going to be good. Okay. You can't see anything here, so you have to take my words because it's too bright. But I can see it very nicely. But this is a cross-section of a gut. This is the lumen. And this is, each different cell is being colored differently. What divides us from the outside world is single-layer cells that cover the entire intestine. Imagine a medieval city with a wall that we build around so that we protect us against the invasion of enemies. That's the way that this single-layer cells that works. In the past, the intestinal function was vilified by saying the only thing that this organ does is to digest and absorb foodstuff. That's the probably least appealing part of the job of the intestine. It sure does that, and without that, we will not exist. But also, with this barrier function, keep the enemy at bay. Also, on the surface of these cells, there are antennas, there are sensors, what we call pattern recognition receptor, that is inform us, do we have friends here, people that we want here, or enemies that can really attack us and disturb us. And not only that, but they have a capability to communicate this information with the army of soldiers that are there to defend us in case that an attacker will make through the walls. And these are the immune cells. And again, the fact that the intestine is the richest immune organ that we have in our body speaks volumes, starting from this green one, these dendritic cells. They can send periscopes outside to sense who is there and coordinate this response with the epithelial cells. And then we have a specialized part of the army. They are this cell in blue, the B cells. They can really customize weapons. They are lethal for the enemies. They are called antibodies. And these weapons can even be shot into the lumen so that the word stays outside the wall of the city with the secretory IgA. And finally, the most interesting one are these guys here, the T cells. When activated, they have high, heavy artillery. And when they shoot, they create severe collateral damage that is called inflammation. For example, are the T cells, as you heard this morning, the one that create the enteropathy that characterizes celiac disease. The other thing that is interesting about these cells, not only they stay on the battlefield to fight, but they sometimes, for reasons that nobody knows, and who will discover that will surely win the Nobel Prize, are programmed to leave the battlefield and go somewhere else. Somewhere else where? The joint, and you do rheumatoid arthritis. The pancreas, you do type 1 diabetes. The brain, and you do MS. And I can go on and on and on. Because they can create this inflammation somewhere else. Now, the premises that we've been working with, and I just heard today that I'm so glad that we didn't discuss this morning, that Fritz is really skeptical about this. And again, now this was a working hypothesis been embraced by many folks. It's been already published 6 years ago. So this is not even an object of discussion. It looks like that the process goes from left to right. Under normal circumstances, there is a very, very tightly controlled antigen trafficking. These molecules can get in only and if when we want them to come in. And again, this is something that is tightly controlled. This is called antigen sampling. So learning the environment. And when we do that through the use of specific cells, of specific cytokines and so on and so forth, we create what we call mucosa tolerance, energy, so we stay healthy. It's like training the immune system as an athlete just to be ready to fight and to run if and when you have to perform. The problem arises when there are minor barrier defects. These are not damaged intestines. Not that you do the endoscopy like Fritz was saying, you're going to see anything. There is nothing. These are functional defects in which now this trafficking of antigens coming through is not controlled anymore. If we go back to the parallel of the wall of the city, when you have the levee bridges to bring merchandise and friends in, they need to be closed in order to prevent the enemies to come in. But if they stuck open, that's what's going to happen. These flows start to be unregulated, and now what comes downstream is depending who genetically you are. If indeed you're predisposed for any of these chronic inflammatory diseases, you start to really fight and you create inflammation. This inflammation will bring you in this vicious cycle because you produce chemicals or cytokines like pro-inflammatory cytokines, like interferon gamma and TNF-alpha that by itself will increase gut permeability. So you have antigen coming, cytokine produced, increased permeability, antigen coming until you break the tolerance, and now you are at a point of no return. And you have the chronic inflammation that characterizes these conditions. So I want to really work a little bit now on this part here. What really brings to the break of the barrier? Again, we didn't know anything about this. We were under the impression, we were taught, that the intestine is indeed a long tube. It's 200 square meters if you put flat on a floor to cover a double tennis court. And I saw that Marcelo, I learned that is a tennis, trainer, so he will appreciate this. And also that the cells were considered as a sort of, tiles. And everything in between cells was cemented by, this grout. So the communication with the external world could happen only through the cell and not in between cells. That's the way that this was conceptualized. So no levee bridges, it was an entire wall, no way of communicating. In the mid-70s, a Japanese group said, no, there is not a wall in between cells. They are gates. Most of the time closed. They call this the tight junction. But they are indeed like levee bridges. Even if they're most of the time closed, they have the capability to be open. And the following 2 decades brought a wealth of information on how these junctions are made. More than 200 proteins make these junctions, and there is a lot of redundancy. And in biology, there is a lesson that never fails. When you see redundancy, that means that that function is extremely, extremely important. What happened, though, in the face of this progress of information of how these gates are made, we did not have any information who and why and when these gates can be opened until we stumbled on this molecule, zonulin, by serendipity 15 years ago. And this molecule, without going too much in details, is capable under specific signaling from the environment that I will show you in a moment to trigger a chain of events into the cell that brings these gates from close to open in a matter of a few minutes. And this is a Fritz fracture, so you have 2 neighbor cells. Imagine these 2 neighbor cells that I break, and now you see the face of the cell that face the other one. These are the microvilli that face the lumen. This is the cell body, and this meshwork here are the tight junction. The more complex, the more it's closed. And if you release zonulin, you go from this close to this open in a matter of a few minutes. The discovery of zonulin in 2000 saw a dark time. For 10 years, we've been trying to figure out what the heck this molecule is. And after 10 years, finally, we put our hands on this molecule that turns to be the precursor of a very, very ancient protein that is called haptoglobin. Haptoglobin comes in 2 flavors, haptoglobin 1 and haptoglobin 2. Only this guy here, the precursor of haptoglobin 2, is zonulin. These molecules normally are cleaved on this side here to create these 2 subunits, and that's the mature form. The mature haptoglobin 1 and the mature haptoglobin 2, they have no business to open tight junction whatsoever. They do another business. They scavenge up, hemoglobin in case that there is hemolysis, intravascular hemolysis. Why? Because hemoglobin will be extremely dangerous to tissue, will create, oxidative stress. So sequestering hemoglobin is the way to protect tissues. While the entire molecule, the one that's not, that it will be this molecule here, it's 47 kilodalton, so the precursor of aptoglobin 2 is the one that's open the tight junction. And the reason why it took 10 years to find it, because never ever been described that a pre-protein has any biological activity. Now, because there are these two forms, aptoglobin 1 and aptoglobin 2, people can be in one of these three categories. You have 2 copies of the aptoglobin 2, meaning 2 copies of the zonulin gene, so you're homozygous. You can be homozygous for aptoglobin 1, so you do not make zonulin, or you can be heterozygous, okay? And interestingly enough, if you see the general population, 1/5 of the general population will have 1 copy, half of the population, 0 copy, I'm sorry, so they don't make zonulin. Half will make 1 copy, and the remaining 30% roughly will make 2 copies. But when you see autoimmune diseases, like type 1 diabetes and celiac disease, now you see a skew toward the double copies of the zonulin gene, and a reduction of the number of people in that particular population with, 1 copy. And we see this even in first-degree relatives, so people that don't have the condition. What is interesting here, it was already described a long time ago, that having this haptoglobin 2, particularly in homozygosity, increased morbidity and mortality for a series of conditions. And nobody understood why, because the mature form actually doesn't do anything other than protect us. The other thing that is interesting here is that, and that was expected, if you plot, the zonulin values that you can measure in the serum, you see that the values are proportional to, the number of genes that you have. So if you don't have anything, it's pretty much baseline. So this is the baseline value. But if you have 1 copy or 2 copies, you increase the amount of zonulin they measure. Much more in autoimmunity, so you see the slope is much steeper than in control, even if here there is a similar correlation. Also interesting is that the only bona fide test for gut permeability, i.e. the lactulose mannitol double sugar that we've been using, even if it's very finicky as a test, and you plot this against these aptoglobin genes, you have the same correlation. No zonulin, no increased gut permeability, 1 copy middle, 2 copies sky-high gut permeability. Interestingly enough, the genes for zonulin sits on chromosome 16, tiny chromosome. Only 3,000 genes, 3% of the human genome, but packed with genes that are really affecting several conditions of chronic inflammatory diseases like autoimmune disease, cancer, and disease in the nervous system. When the zonulin gene was cloned in 2010, a lot of groups worldwide looked at the distribution and found the same 3 categories. So zonulin gene has been associated to a series of autoimmune diseases, including celiac disease, Crohn's, RA, lupus type 1, cancer, including brain, breast, lung, ovarian, pancreatic cancer, and interestingly enough, to MS, schizophrenia, and now autism. The last publication just came out. And this now, if you look at the literature that is coming out, now this is a list of all the conditions that have been found to be associated to zonulin. The only 2 with negative results are the iron metabolism in transplant. I'm not sure why they look into this. It's psoriasis, in which there is no increase of zonulin. And all the others, if they look at, including celiac disease, IBD, glioma, irritable bowel syndrome, HIV, and so on and so forth, you can go down. Also type 2 diabetes, and so on and so forth. There is a strong correlation with this molecule. What are the stimuli that really cause zonulin release? The 2 strongest stimuli that we have been seeing are gluten, and we discussed briefly this morning, and the microbiome. That brings me back to the argument so I can close the discussion here. We already discussed that this receptor, CXCR3, is the one to which these two fragments of gluten binds to, so we know exactly which is the target receptor. So, just to, paraphrase what, Fritz was saying, if you don't know the receptor, I'm skeptical that the innate immune response is involved, but this is definitely been published by another Dutch scientist that would be working on this, and microbiota. So if you use microorganism, it will make the immune cells, and most importantly, the epithelial cells, to release zonulin. This is what happens if you put a microorganism on the surface of this epithelial cell. This is the nucleus, this is the cytoskeleton, and these are the package of zonulin that is performed, that is put in this vesicle and released right away. And releasing this molecule means making intestine leak. This is a drop that makes, it's the measure that the intestine is going to leak. What is interesting here is now that we know that there are conditions like endotoxin, like LPS, that if they come through because of loss of barrier function, can drive big-time inflammation. And now we see, for example, that this is the case for type 2 diabetes, non-alcoholic fatty liver disease, type 2, obesity, and so on and so forth. There are the protection from the microbiome. So this is harmful, but for example, short-chain fatty acid like butyrate, that will protect. And bile acids will complicate a little bit more the story here. I'm going to stop here. But all this to say that gut microflora, intestinal barrier, and the gut-associated lymphoid tissue, so the immune system, they really play this game, interacting and being influenced by a series of external factors that can really change the dynamic here. This is a very busy slide. I don't pretend you can see it, but it suffices to say these links environmental factors to final outcome, to say this is the driving force. This can be prenatal, perinatal, postnatal, and all this will impinge on this. The microbiome composition. This turns to be the transducer of all the environmental factors can bring us to chronic inflammatory diseases through a loss of barrier function, increased antigen passaging, immune response, blah, blah, blah. And, how you got down here, again, depends who you are genetically speaking. And this brings me to the microbiome. I don't have to spend too much time because I'm pretty sure they've been reading this. There is now that we have a way to look at the entire microbiome, we discovered that we have many more microbes than our own cells. The genes outnumbers ours by a factor of 100 and so on and so forth. Word of caution here. Now that we know this, are we ready to apply this information for clinical applicability? For example, using probiotics or that kind of stuff? Not really. There is a hierarchy of the microbiome, starting from the domain all the way to the species. The vast majority of the studies are here, the film level. And this is way too far to understand what's going on. It's like to say universe, Milky Way, solar system, Earth, Europe, Netherlands, Leiden. Well, forget about that. This is where I'm going next. So, anyhow. But if the studies are here, it's like to pretend that you want to come to Leiden and currently you are just entering the solar system. There is far from the target, So start to think about manipulating microbiome with prebiotics, probiotics, or fecal transplantation. I know that we will be able to, because we will get to Leiden. I know that we will, but we are not quite there yet. So now we're just shot in the dark. What is important, and you need to learn this lexicon, because this is going to be clinical practice, is this. Yeah, it is important to know who's there, i.e. the microbiome. But even more important is to learn what kind of language these microbes can talk. In other words, what kind of genes they have, and what they are talking about, which genes they are expressing. And these are the metagenomics and metatranscriptomics analysis. So we tell us exactly how they can communicate with us. Because this is what is the essence of taking the wrong turn and losing tolerance. And this, it will be this part here, the ecology, how they interact with us. So, yeah, we need to know who is there. We need to know what kind of job they can do. But once they are in us, how this really translates. This also was said this morning, and I have to reiterate. Contrary to our belief, the small intestine is not sterile with the exception of the colon. Of course, the vast majority are here. But we have a wealth of microorganisms in the small intestine, even in the stomach. pH 2, we have a wealth of microorganisms there. And now that we use and abuse of proton pump inhibitors, this has become even wealthier because one of the major way to kill this huge number of bacteria that we ingest every day is gone because we're neutralizing the pH. Of all the stuff they have to say, this is the most important slide. So if you were, got in this afternoon kind of sleepy mode, just wake up for a second. If you're lucky, you're on this side of the slide. You're born in the way that Mother Nature told us to be born. You've been fed real food, no infection, no antibiotic treatments. These will make the composition of the microbiome extremely balanced. Let me tell you something. The immune system was engineered 2 million years ago, I said this already, was engineered to fight one single enemy, microorganism. There were no cancer at that time. There were no pollutants or chemicals, or gluten, by the way. These are enemies that came recently. At that time, our ancestors would die either of infection, that was the most likely way that they died, or a predator will hit them. That's it. So don't be surprised that is the microbiome the best trainer for the immune system to decide if and when to unleash these deadly weapons that will create inflammation. And should not become as a surprise that a balanced microbiome will teach the immune system to do this the right way. So to put the bar to unleash this weapon extremely high when we really, really are in danger. Now, if you are unlucky, you're on this other side. You're born by C-section, inappropriate nutrition, multiple infection, use and abuse of antibiotics. The microbiome is out of balance. Now is putting this bar, is teaching to this immune system to unleash inflammation even when it's not necessary. So the immune system is being taught by the microbiome to be extremely belligerent and on a specific genetic background. This will put you in a major risk to develop chronic inflammatory diseases. The game is over in terms of where you set the bar after 1,000 days after the first 3 years of life. So the first 3 years of life of how the microbiome of our babies are composed is going to be instrumental. Look at this, factors. In your opinion, of all the ones that are listed, what is the most influential in dictating the composition of the microbiome, deciding if you're going to be here or here? By far. You're born only one time in life. You may get an infection here and there, or antibiotics occasionally. You eat 3 times a day. So nutrition is important. Mother Nature tells us so. This is the composition of the breast milk. These HMOs here, human monooligosaccharides, useless to feed the baby. The baby cannot make use of these sugars. They are there for only one reason, to feed the good microbiome, the one that sets the bar very, very high. And if you eat differently, your microbiome looks differently. So if you're herbivore, you will be distinguishable from the carnivore, that you will be distinguished, we should be all omnivore, because human beings are supposed to be omnivores. Bringing back to the celiac disease, no answer, so maybe that is the microbiome composition to run the show here. And once again, Fritz was very skeptical because he said, there is no microbiome in the small intestine, and this is a small intestine disease, but actually, it turns to be that the microbiome of babies with celiac disease is very different from the normal babies. Now, I don't want to cut into the details. Just look at the colors. That is a heat map. This color looks very different from this. This color looks very different from this. This is different from this. That means there is different composition in microbiota. Now, do we have an answer? No, Because the fact that there is an association, so that in other words, that the kids with celiac disease are here with this microbiome, and these other one are here, it's just association. It doesn't mean that this difference is what is causing celiac disease. Because association does not imply causation. Otherwise, the more chocolate we eat, the more likely we win the Nobel Prize. And we know that this is not the case. Okay? There is no direct link here. To move from association to causation, there are paths that we have to go through. They are very, very determined and clear-cut. And now we have the technology to really move from association to causation. I was mentioning, for example, today that we are able now, through routine procedure like an endoscopy, to recreate the gut, these gut organoids, from an individual with celiac disease or an individual that's normal. And now we can ask questions. If I put on these organoids, this microbiome versus this other microbiome, gluten or FODMAP or whatever, what is the outcome? And what we can do, we look at the genes. Before and after that we're supposed to say, we can now look at the entire genome of this individual from which we got the organoids. And we can, for example, in this case, find out what is wrong. To conclude, guys, over the years, we really got to appreciate that the human body is definitely the most sophisticated machine on the face of the earth. When the Human Genome Project was terminated and finished and completed, I was very distressed and my self-esteem went to the toilet to learn that we are made by only 23,000 genes. Only 23,000 genes. A worm, the one that we're fishing with, 75,000 genes. The plant that makes gluten, wheat, 150,000 genes. We are genetically rudimental, and yet we're the most sophisticated machine on the face of the earth. The reality that we are made by two genomes. The stable one, the one that if I have genes that put me at risk for MS, celiac disease, Alzheimer, are there. Can't do anything about it. The fact that those genes are there is not necessarily mean that they will translate in clinical actuality. If they do or do not, depends on the microbiome. Because this changes all the time. And this can influence if and when these genes are expressed, as I showed you a moment ago. Typical example, C-section. 5 times more risk to develop celiac disease if you're born by C-section than vaginal delivery. Why? Check this out. Mother's microbiome in the mouth as a control. In red, you have the microbiome in the vaginal and fecal microbiome in mom. In pink, the microbiome of the baby. The baby inherited the microbiome of the mother if it's born vaginally. And that microbiome, if it lives in peace with mom, will live in peace with the baby. If you're born by C-section, the microbiome in the baby, light blue, is the skin microbiome of the mother. That's not selected. They're all comers. You know, the nurse there is in the OR and so on, the surgeon and so on and so forth. So if you allow me, the human genome is the piano with 23,000, notes. Who plays the piano determine if you play the song celiac disease or whatever. Let's say that you have to touch 300 of these notes, and you're born with Elton John that touched only 200. And then something happened, even when you're 60. And now Chopin is virtuoso to touch all 300. And then you develop the disease. That is the epigenetics at its best. And that's what we understand now. And we've been entrusted by the NIH to do a study just to look at the crystal ball. In other words, this study takes babies at risk of celiac disease and will follow over time. And will interrogate, what was your microbiome before and after birth? Because the microbiome starts in utero. What pre, peri, and postnatal factors really change the story here? What about the way that you're born? And most importantly, the way that you're being fed. And so we can really find the genome, the microbiome, the metabolome that would bring you to the wrong direction. And the idea is, here, these 1,000 days, we want to really get in here and change the course of what is the destiny, not change the genome. We can't change the piano. It's too expensive. But change the piano player so that that song, celiac disease, that song, MS, that song, breast cancer, will not be played. How long it's going to take? I don't know. It depends on these guys, because I am simply the director of the orchestra. These are my maestros. And, you know, again, it takes the humility of people that are willing to play together in the same sandbox. And most importantly, with the open-mindedness that everything is fair game if we really want to move this forward. No preconcept, no boundaries, because this is the way that science will progress. Thank you.
Vragen uiteraard.
Yes, thank you. I was in Stanford last year, and they explained this as well. They more or less related that to the bacteria in the soil. Do you see that relation as well?
Oh, big time. Again, if we really want to give justice of the ecosystem, the microbiome, we have to spend 3 days and not 45 minutes. You know, the concept that I was trying to communicate to you guys, that, you know, if you take the human beings and you take this out of the context where we live, how we, you know, behave, what we eat, we will not understand exactly what we are or who we are. Because, again, 23,000 genes, if they are not integrated by 100 times more genes from the microbiota, you would not appreciate who we are. Now, of course, where this microbiota comes from? From the environment, including the soil. You know, we don't do this anymore, but when I was a kid, I was used to play in a place that was called backyard. It's not in Wikipedia anymore. That was the place in which we were allowed to put the hands on the dirt and then put it in the mouth. Now, that changed the microbiota composition. If they stay or not, or flourish or not, depends on nutrition. So nutrition, the shape, the microbiota, based on what is coming in. And the soil is the source, and the water, and the atmosphere, and the plants that we eat, and the animals that we eat. Because, you know, guess what? Let me break news. Nothing is sterile in life. So we ingest a huge amount of microorganisms every day.
Can you tell me something about the sensitivity of measurement zonulin in serum or measuring it in stool?
I cannot. And the reason why, because, you know, there are not enough studies to validate, you know, what is the best method. I've seen it in the literature, studies in which they've been measuring zonulin in the serum, and I've seen this in stools. You know, I think that it's too early to say which one is the best method. There are many more studies on serum zonulin that links to those diseases. Those are the studies that I show you. So I think that the evidence is becoming now solid there. I don't think there are enough in the stools really to say that this will be a validated source to check for zonulin.
Thank you for the talk, first of all. You seem to focus a lot on the first 1,000 days of life. Why is that? Why not in adult life?
Now, again, the point, again, very provocative that I was trying to make is that, you know, if you're out of luck that you're born with the genes for whatever disease, and on top of that, during the first 1,000 days, you have a lifestyle that makes the immune system belligerent, now you almost put together the perfect storm. Does it mean that necessarily you would develop the problem? Absolutely not. If the rest of your life you will have a good, you know, behavior, okay? Eat well, you exercise, you got at least 7 hours sleep, you don't smoke, you know, again, that threshold, even if it's so low, will be rarely overcome. Conversely, if you did everything fine and the bar is up there and you really have a sloppy, sleepy lifestyle, trust me, you will be able to go over that threshold. It's like to say, can we all, you know, develop lung cancer? Of course we can. But if I smoke 2 packs of cigarettes a day, I'll have much more chances. That's what we do in the first 1,000 days of life. If we have that lifestyle that brings the bar that down, we'll increase the risk.
What do you think is the main factor explaining the epidemiology, so the steep rise
So again, we thought there was the hygiene hypothesis, and again, because we were convinced that, you know, microorganisms are enemies and they need to be combated at all costs, we realized that actually we cannot live without them. They do so many good things to us, not just for the immune system, but again, they provide us some nutrients that we can't really have with the diet, and they have the capability, again, to keep our immune system in shape and so on and so forth. So definitely, that was a logical hypothesis. However, when the hygiene in the countries that are below the equator increase as well, so they have pipes, they have sanitary water, and they, you know, they are exposed to the kind of, you know, infection that they had before, they didn't see this epidemic occurring. However, the same kids, if they were migrating, you know, our places, they got the same epidemics as the kids here. So there's something in the environment. And again, my bias is nutrition, the way that we feed our kids and ourselves. We call food stuff that food is not. In only 3 generations, we dramatically changed the way that we eat. 3 generations ago, so our grandparents, so not 5 or 6 generations ago, did not have a refrigerator. There was no way that you can put stuff in the refrigerator in the freezer. So you have to produce and consume locally. I was telling somebody, I can't remember who, I grew up, and again, I'm young, very, very young, not knowing what a kiwi was. Never seen one in my life. If you have a fruit salad now without a kiwi, you are really, you know, a moron. It can't be. Or strawberries, July and August, and that was it. I'm wondering, forget about, again, you know, the chemicals that we put on our food, the pre-packed foods with so on and so forth with all the chemicals, but just the way that we do this. The fast food, the way that we eat, how impactful it has been. Again, for 2.5 million years, we built a car with a tank to put gas in there. What is the gas? Fresh fruits, fresh vegetables, lean meat, because at that time the animals were running around, fish, tubers, nuts, olive oil. I'm just describing the Mediterranean diet.
Paleo diet.
Or the paleo diet, whatever you want to call it. Now, the more you diverge from this, the more you pretend to run the car putting Coca-Cola in the tank rather than gas. And first, Coca-Cola, I should not have said that. But, you know what I'm talking about. So I truly believe that diet is, you know, one of the key culprits here.
I don't know if there's any evidence, but maybe you do know. It's my impression that the development of early tonsillitis could be a signal for foods that are coming in that children cannot
tolerate.
Okay.
Exactly,
thank you.
I don't know, honestly. I have no idea. I was under the impression tonsillitis was the consequence of a rich lymphoid tissue doing its job when it's exposed to microorganisms all the time. Now, if this is due to the fact that the food is determined that, I don't know, honestly.
The gentleman up there.
Yeah, nice talk. You listed as environmental factors, you listed gluten and microbiota. You also listed a slide where many diseases correlate with zonulin. Now, many of these diseases, there's also extensive drug use. So can you comment on the effect of drugs on zonulin release and also on the effect of alcohol consumption?
That's right. So, I don't want to leave you with the impression, otherwise I will do the same mistake that's been perpetuating forever, that, you know, gluten, microbiota, and zonulin, and that's it. You know, these are complex diseases. How you reach that final destination can be very different from one individual to another, and that's the reason why precision medicine or personalized medicine, I believe that it's the future. As a matter of fact, for example, the 20% of the general population or the 10% in the type 1 diabetes that don't have the zonulin gene, this mechanism cannot be operative. There must be some other molecules that we didn't score yet, but definitely must be there, that control, permeability. I can comment on alcohol. For sure, alcohol is a factor for other reasons that can increase the release of zonulin. I don't know anything about drugs because I've not seen anything in the literature. By the way, now there are almost 200 papers in the literature. I contributed at a minuscule number of those, and mainly at the beginning of the story 10 years ago. So I'm not sure, and again, I keep an eye on the literature, if anybody systematically been studying, zone release after, specific medication drugs.
Okay, Jan?
Ja, of ik hem in het Nederlands stellen mag. Ik heb misschien de scherpte van het verhaal een klein beetje gemist. Maar sinds 1975 is er een explosie van auto-immuunziekten, autisme helemaal het ergste, geweest. En gelijktijdig is in de westerse wereld advies van vetarme voeding in opkomst. Met ontzettende toename van het gebruik, het consumeren van koolhydraten, met name ook snelle koolhydraten, de verwerking van voedsel, eetjes. Het is een hele optelsom die eigenlijk voor afbraak van het microbiome zorgt, denk ik.
I got 80%.
You got it?
Unbelievable. Well, yeah, we're talking about autism, we're talking about the epidemics.
Yes, since the 70s he says. And his question is this related to the advice to basically eat more
refined food?
Yes, that's what it's... And less fat. That was the question. We are told to eat less fat. We don't know if people actually do this, but we can conclude that they eat more refined carbohydrates for some reason.
So autism is the classical example in which generalized statement that cannot be made. Let me explain. For example, there is definitely a subgroup of kids that reach this final destination because of genetic reason, Fragile X. Other kids that reach their final destination because oxidative stress. Other kids because of food intolerance. So in other words, we know that there are a group of casein-free, gluten-free diet that seems to do extremely well when they go on that diet. The only thing that I can tell you is that the classical food pyramid in which we put on the bottom fruit and vegetables and on top fat animals has been so deceptive in really instructing us the proper way to eat that it creates more harms, in my very humble opinion, than helping. Because we demonize, fat, for example, when we now know, for example, that it's instrumental to brain development. So we know, for example, that refined sugars are handled by the immune system. I didn't have the time to show you, but even the dulcifiers, the one that are in the, sugar-free products there, they have such a negative impact on the composition of microbiome. Why? Rather than to have a community that is diversified, only few microbes can use that particular sugars, refined sugars. The ones that they thrive on what is the leftover of fat also are gone. What is the consequence? They're either there to have a diversified composition that check each other, stay in balance. Now you have a less diversified microbiome. And some of these species start to really thrive and become bossy. And that's the essence of the dysbiosis. It's just that they're not in balance anymore.
Ja, hij verkort nog één fact. Omega 6. Omega 6.
Once again, this would take an entire new lesson in terms of omega-3, omega-6, and I believe that we will not give justice to what we have to discuss. It's suffice to say that it goes back to the concept. What are you putting in your tank? At the time of our ancestors, the lean meat means that the amount of fat and the balance between oleic and linoleic fatty acids was very, very different from what we have right now. Very, very different. So it seems to be such a no-brainer to say, what is our best way to eat? Go back where we came. The more we depart from that, the more we will be in trouble. I'm not advocating the paleo diet, even if you do guys have, this soft heart for that. I'm advocating in general lifestyle and nutrition that has common sense. I know for you is, the paleo diet. For me, call it paleo, Mediterranean, but it's something that is balanced and provide the right balance of nutrients that keep my guts in good health and therefore me in good health.
Anyone? Yeah, okay.
I had one question. You mentioned that the innate immune system was not triggered by toxins, etc., because they weren't there. But haven't we always have like plant toxins in the food and natural arsenic sources for the water and like smoke toxins, etc.? So I think that, I was assuming that from an early point in the development of humans, we were actually quite often exposed to toxins. Could you comment on that, please?
Yeah. Again, as I mentioned this morning, we now are bombarded by many more enemies. The immune system, over the years, rather than fight only microorganisms, have to fight, toxins, pollutants, chemicals, you name it. The essence is how good is the immune system to get rid of these enemies, and what are the consequences? And this depends, again, genetically who you are, where this bar is. If the bar is high, you are exposed to this stuff. You engage the innate immune system, but the immune system has been trained to take care of it. So you don't pay consequences. But if the bar is low, with the same amount of exposure to this stuff, you will pay consequences. What are the consequences? Again, depends who you are. Some people, those T cells that I show you, that white cells, if they will leave the intestine and go to the brain, you can develop autism or schizophrenia or MS, depending who you are. Or they go to the skin and you develop issues there. Or you could develop a Th2 response and you develop multiple food allergies. And I can go on and on and on. But once again, what I want really to stress here is these epidemics, if they are in a rampage, because there is a reason why, there must be a way to stop them. The question is how? And we're in the kind of verge of revolutionary, change of the trend if we, again, do the job right, if we play the game, in the right way. Not rushing, try to find the solution, but really to understand how we made this perfect storm and what we can do to really bring back the situation.
Yes. I think we still have time. Okay. Two short questions.
Maybe another question. We know that the fetus in the uterus is not sterile. Do you think, or not do you think, but what is your opinion about? Do you think this is like kind of a blueprint in the uterus already? And maybe I think we don't know what is the function of it, and do you think it has what is the impact? Maybe it does not even. I think it matters the way you were born, but maybe this blueprint even is more important. What do you think about it?
So again, another day of lesson here, but our group was the pioneer to show in an animal model first and then in humans that the fetus is not sterile. This game is played the last trimester of pregnancy. So while the placenta really compartmentalizes everything, in the last trimester, for reasons that we didn't understand at the beginning and now we appreciate, allows some stuff to come through. How this happened? Do you remember that green cells that I show you that can send the periscope out, the dendritic cells? During the last trimester, it looks like that they put this periscope out and they choose the good bacteria. The mother decides what kind of bacteria she wants to imprint the baby with. will bring them in their, cell, and through the bloodstream of the placenta will release that in the meconium. The kids swallow it, and that will colonize. If the mother smoke heroin, smoke marijuana or his own drug, or smoke cigarettes, or eats junk food, in other words, stuff that will destroy or imbalance her microbiome, she will deliver the wrong microbiome. If she's forced to take antibiotics for whatever reason, of course this will impact in a negative way what will be delivered to the baby. But in my humble opinion, again, it's fascinating how Mother Nature, by different angles, is telling us that establishing and maintaining the microbiome is instrumental to stay healthy.
Last question.
So you agree that the blueprint is maybe even more important than the way the baby is born?
Well, again, as I was saying before, the blueprints is instrumental to start, but then you have to maintain. Because if you change the lifestyle, and that will destroy what has been, is established, it's like that you have a beautiful, piece of land that you prepare, put seeds in there, and then you don't water the seeds anymore, and the plants will not come out. So you got to really take care of it.
Yeah, but let's say the mother, the blueprint is not good because of the mother had antibiotics or whatever, and you give a good, the baby is born good. Do you? Yeah, I think we don't know yet if we can.
We are at the solar system. We don't know yet. When we're going to land in Leiden, we will know what to do to put this back where it's supposed to be. It will take time.
It doesn't seem to be Leiden, unfortunately, this time, but...
Well, whatever.
Okay. All right. Well, I think we have to close here. I had the question about zonulin, why only 20% of the population expresses it, but do we have time to answer to go in on my question? Okay.
So what is the question?
I realize you told us that only 20% of the population expresses zonulin. Is that
no,
right?
80%.
Doesn't express, sorry.
That's right.
Doesn't
20
express
does not.
zonulin. So that tells us something. How do these people do without zonulin at all?
But once again...
what does it say about the function of zonulin and the necessity?
Again, once again, I told you redundancy is, a clear sign of an important function. If indeed modulating permeability, as I believe is an important function, I will be shocked, tremendously shocked that the zonulin is the only one that can do that. Got to be other 100 molecules that would do that. We didn't discover that yet. But what is intriguing to me is that this 20% goes down to 10 in the ones that they have autoimmunity. And that means that, again, it's a disadvantage to have too much. And, of course, once again, you saw in the first-degree relatives, the fact to have too much zonulin may be necessary but not sufficient. You have to have those 5 elements. So if you have an increased permeability, but you have a good microbiome, or the immune system is doing the stuff right, or you don't have the genes, you will not pay consequences. You got to have those 5.
Could it be that people that have a very high zonulin expression are, in the natural environment, more protected against infections?
I don't think so, because again, the amount of zonulin, as I show you, correlates with increased gut permeability. I see the advantage to have the capability to go on and off. Okay. So if you have a chronic increase in zonulin, I don't think that is advantageous. On the other hand, if you have 2 genes, and therefore you're capable, when it's requested, to release more zonulin than another individual, that can be advantageous to protect you, for example, against infection, because that's exactly what this system does. When there is colonization in the small intestine, zonulin release, you open this junction, water goes in, and you will shut these folks out of there so they don't settle.
Thank you very much. Well, thanks again.